Hello again. In the previous lesson, we worked with things called vectors and their applications. Now we're moving into something called conic sections. Conic sections include things like parabolas, circles, ellipses, and hyperbolas. Okay. In this lesson, we will identify the main conic types and focus essentially on parabolas. Okay. So let's begin first of all with the quick rules. Conic sections include things like parabolas, circles, ellipses, and hyperbolas. A parabola is the set of points equidistant from a focus and a directrix. Vertical parabolas, the vertical parabola form is x minus h squared equals 4p parentheses y minus k. So it's good that we have formulas because this is the vertical parabola and then the horizontal parabola form. When we have these formulas, these forms are essentially something they just have to memorize. The more you write it, the more it'll be committed to memory. Okay, so practicing it is absolutely essential. All right. Example number one, let's get right to it. So we have to classify each equation. We have several equations here, A, B, C, and D. So let's start with part A first. We want to start with x squared plus y squared equals 25. So both x and y are squared, as you can see. X and y are squared. They have the same coefficient. Notice they both have 1 as a coefficient. So that gives essentially a circle, right? So x squared plus y squared equals 25, the circle, right? And that would be the conic type, okay? Part B, now we're looking at y equals x squared minus 4. So only x is squared in this, and y is not squared. So that gives a parabola, okay? So a y equals x squared minus 4. Notice the x is squared, so this is parabola. Okay? And a parabola is essentially like this. And whereas this is going to be circle. Okay. Both are squared. And so it's kind of interesting because the x is squared, so it kind of gives you like a almost like a semicircle, which is sort of what a parabola looks like, right? Next, C. Now we look at C, which is x squared divided by 9 plus y squared over 4 equals. Now notice both variables are squared and the terms are being added. Now the denominators are also different, right? So we have to look at that. What's going to happen in this case is that is going to give us what is called an ellipsis. So x squared over 9 plus y squared over 4 equaling 1. That is an ellipsis. And then finally, part D, we have x squared minus y squared equals 16. Okay. So again, both variables are squared. Both variables are squared, but the terms are subtracted, not added. So since the terms are subtracted, this would be hyperbola. Okay. That would be the conic section. So the conic sections are as follows. When you look at the variables are squared, they're added, therefore it's a circle. Here, the variable is squared, only one of them, therefore it's a parabola. Here, we have both variables squared, and they're both being added. However, their denominators are different. That's going to be an ellipsis. Here, we have both variables squared. However, they're being subtracted. That's a hyperbola. So just memorize this, write it over and over, commit it to memory, and you'll be excellent when it comes to conic sections, identifying them and their constituents. Okay, example number 2. For parentheses x minus 2 squared equals 12 parentheses y plus 1, identify the vertex, the p-value, the focus, the directrix, and the direction of opening. Okay, so first of all, we got to compare the equation to the vertical parabola form. Okay, so the vertical parabola form is parentheses x minus h squared equals 4p parentheses y minus k. Okay, because this is dealing with the um, parabola features. Okay, so looking at this, right, we want to compare this to the parabola. So our equation is x minus 2 squared equals 12 parentheses y plus 1. All right. Now, essentially what we can do is we can rewrite this here, right? Because this is the change in y. So the way this would look is actually x minus 2 squared equals 12. And essentially that, whatever this is, I don't want to speculate, but this will be just 12, and then this will be y minus negative 1. Okay. So the vertex is as follows. The vertex is, and just comparing this to the original. So we have h, and we also have k. So in this case, hk be equal to 1. Now we need to identify 4p. Okay, so 4p is going to be equal to 12, right? 4p is equal to 12. So 4p is equal to 12. We divide by 4. P is equal to 3. Because the x expression is squared over here, this is a vertical parabola. And because p is positive, the parabola opens upward. Okay, because you got to think about this stands for period. That period would be down here, then it would open up like this. Okay, so again, the direction would be up. Okay, opens up. For a vertical parabola, the focus is p units above or below the vertex. Since p is positive, we would move up 3 units from the vertex. Okay, so again, since p is positive, that we're essentially moving up 3 units from the vertex. So the vertex is here. To -1, and then the focus would be 2 comma -1 plus 3, which is parentheses 2, 2. So this is the focus, right? We have the direction, we have the P, we have the vertex, right? Now the directrix is P units on the other side of the vertex. So since the focus is above the vertex, the directrix is below, right? So the directrix is essentially y equals -1 minus 3. which is y is equal to -4. Okay, so the final answers are the vertex is as follows. All we had to do was simply rewrite the equation. And then we found P, and then we found the focus point by shifting it, right? Which is the change in y. And then we found that the directrix would be that shift down, which is -4 from here, right? And again, this parabola would open upward, right? Continue. All right, pause and try the following problem. Okay, so the horizontal parabola form is y minus k squared equals 4p parentheses x minus 8. And I didn't explain this, but like notice how I knew this. You're probably already tracking on it, but it's x minus 2, so the same. So the vertical parabola, you see this will be a vertical parabola. Horizontal parabola is y minus 2, etc. Okay. All right, so we have y minus k squared equals 4p parentheses x minus h, and then we're going to compare that with what we have. So we have y plus 3 squared equals 4p parentheses actual -8. Got for erasers. -8 x minus 1. Okay, so we do have to write this, but only for this side, right? We have to rewrite it so that it corresponds with the previous. That'd be minus squared equals 8 parentheses x minus 1. So we have our vertex. It's also HK, which is also -3 and 1. H would be 1. K would be -3. Okay, so we have our vertex. Now we have to find P. So 4P is equal to -8. Divide both sides by 4. We have P is equal to -2. Okay, and then just recall how we found the focus point and the directrix. Okay, so from here we have P is equal to -2. And again, because the y expression up here is squared, the parabola is horizontal, right? Because we're using the horizontal parabola, right? Horizontal parabola, so it looks like that, unlike the vertical parabola. And because P is negative, it's going to open up to the left, right? Because this P is negative, it opens up to the left. So this would be the standard horizontal. But if your P is negative, then it would open up to the left. Now it opens up to the left. For a horizontal parabola, the focus point P is going to shift it to the left or to the right based on the vertex, right? So since P is -2, we're going to move 2 units from the vertex. Okay, so the focus is essentially 1 minus 2 comma 3 -1 comma 3. So this is the focus. The directrix is on the opposite side. So since the focus is on the left of the on the left, right? Because if it's -1 3, it would be over here to the left, right? So -1, -1, -1, -3. Sorry, -1, -3. Let me make sure. Move 2 units from the vertex. Yes. Okay. So that's essentially what it would impact is essentially this number here, right? So because originally the point was 1, and so if we're subtracting um 2 from that, we would end up with -1, -3. So again, that would be moving over here to the left. So keep that in mind. So the directrix is on the opposite side of here, right? Because this is 1, -3. So -1, -3 would come on the opposite side of that vertex, right? Since the focus is on the left side of the vertex, the directrix is on the right. All right. Now the directrix is essentially x equals 1.1 plus 2, which is 3. So the final answers are we have a vertex of 1, -3. We have p of -2. The focus would be -1, -3. The directrix would be 3, and this would open up to the left. All right, let's continue. Example number 3. Write the equation of a parabola with vertex 0, 0, focus 0, 5, and the vertical axis of symmetry. So the vertex is at the origin, and the focus is at 0, 5. Since the focus is above that vertex, the parabola is going to open upward, and the distance from the vertex to the focus is 5, right? So P is equal to 5, right? You see the change in Y here? So the vertex, 0, 0. Focus is 0, 5. And the P, or that change in Y, 5. Now, since the parabola has a vertical axis of symmetry, we can use the vertical form, right? Vertical form is x minus h squared equals 4p parentheses y minus k. So here we essentially have h equals 0, k equals 0, and p equals 5. So we can substitute that information here. We can say, let's see, we can say x squared equals 4 times 5 times y, which would be x squared equals 20y. And therefore, the answer would be x squared equals 20y. Okay, because this would be the vertical axis of symmetry. Okay, so if I were to write this out a little bit, because I was going pretty fast here, so if this is essentially x minus h squared equals 4, and then p was 5, then y minus 0, right? So then you simplify. As a matter of fact, h was 0. Okay, so x minus 0 squared, and then so what I did was I just pretty much moved rather quickly. So this would just give me x squared equals 20, and then this would just be y. Okay, so this is the final answer. I just move very fast. Okay, so I skipped that part in case you didn't understand what I was doing and how I went straight to that. Okay, example number 4. A satellite dish has cross section x squared equals 16y. Find the focus and explain what the focus represents. So the equation is x squared equals 16 times y. What that means is that the vertex is at the origin. That's basically what that means. Just as well as in the same problem that we had before, the vertex would be 0, 0. Now, now from there, we can essentially identify 4p, right? Because we have 16 here. So 4p would be 4p equals 16 divided by 4 divided by 4. P is equal to 4. The period is equal to 4. Now, since P is positive, as you can see, the parabola is going to open up. For a vertical parabola, the focus is essentially P units away from the vertex. So the focus is P units away from the vertex, which would be 0, 4, right? That's the change in Y. Now we need to interpret the focus, right? So in a parabola dish, incoming signals that are parallel to the axis reflect toward the focus. So that is where a receiver would often be placed, okay? So the focus would be 0, 4, meaning that the signals reflect toward the focus. Okay. So for this particular satellite dish, the focus is 4 units above the vertex. Right? Here's a common mistake. The student says that this expression here has a p of 20. Correct the value of p. So for this particular problem, the mistake is confusing p with 4p, right? This is a vertical form because you see x is not written as y, so this is a vertical, right? Vertical parabola. So essentially, we're comparing x minus h squared equals 4p parentheses y minus k. We're comparing that with the expression that we have. So we have x minus 1 squared equals 20 parentheses y minus a negative 2. Okay. So, and then again, I just rewrote this expression because it's a plus, so we have to rewrite it as a negative so that it corresponds with the left and the right hand side over here. So this tells me that the vertex, which is hk, is equal to 1 and 2, negative 2. Now we need to find 4p. I essentially really didn't have to find this, but I just wanted to show you how to identify it. But it says correct the value of p, so we'll just do that. So if this is 20, right, then what we would do is simply set 4p equal to that value, then divide by 4, divide by 4, p is equal to 5, okay? So that's essentially the answer. So the correct value for p is 5, and it's not 20, okay? So the final review is you have conic sections. You have circles, you have ellipses, hyperboles, hyperbolas, and then parabolas. So again, the vertical parabola is as follows. The horizontal parabola is as follows. The vertex is the same as h comma k. And p is essentially 4p equals whatever that value is when you're dividing and trying to figure out what it is. When you have a positive p, that essentially says that it opens up or okay, so either up opening or right opening, and then when you have a negative P, it's down or left. Okay, either a down opening or a left opening. All right, that completes video 15, part 1, conic sections and parabolas. And thank you for watching. I hope to see you in the next one.